All right, so today we're going to start the second of the three topics we cover in calculus. We did limits already. You'll test on that on Thursday when we come back from our day off. And derivatives, we're starting in chapter 2, and then later on we'll do integral. The nice thing about it is, in today's lesson, there's really nothing new. You've been doing it already. What we have to do is marriage the conceptual stuff that I'm going to talk about with the actual math that you've been doing. You'll see what I mean as we get to this. This clicker working here. Okay, so we're going to talk about the difference between tangents and secants. What's a tangent? Not to be confused with the trig tangent. This is the geometry tangent. It touches the thing.
Just 1 point.
In 1 point, good. Versus a secant, what's a secant do?
That's just 1 point.
Beautiful. We're going to find the slope of that tangent line. That'll be fun. That sentence right there is what we're going to be doing for the next probably 2 months. Then we're going to get involved with a fancy definition for the derivative of a function. Just like we have the fancy definition for continuity, we have a fancy definition for derivatives. Then we're going to talk about, if we have time today, how differentiability, things that you can take the derivative of, and continuity, things that are continuous, how they are related. And you should be able to hold your breath before you mess up. If we have time, we'll test it later.
I can make minute rice less than this.
Well, then it's not minute rice.
It is minute rice.
No, it's not minute
I
rice.
can make it less.
Yeah, but then it's not minute. As soon as you make it in less than a minute, it's no longer minute rice.
It's less than a minute rice. No, the package. Yeah, the package says minute rice, right? Plus, but I'm able to make it in like 57 seconds.
It doesn't matter. It doesn't matter what the package says.
No, but it does. The package says it's a minute rice.
You realize you could open that box of minute rice and eat it without even cooking it. Well, you can.
Well, yeah. You can stuff it down your throat, and you can probably choke to death while you prove it.
No, you wouldn't trust it. It would get into your stomach and then it would start to swell.
Oh yeah.
That's why they don't put rice. You can't throw rice anymore away. Because little bitty birdies would come along and eat the rice, and then they would blow up.
That's not true.
We should try that. It is true. Condors would come flying in. Giant 6-foot bird would land on your car and blow up. I've seen it happen. Or maybe not condors. Falcons, ospreys, barn owls. Okay, let's use some technology. Here we go. We did this already. Tangent line hits in exactly 1 point. Notice that we're going to fancy notation again because we're in calculus. It's not x comma y. That's bush league stuff. We're doing x comma f of x because that's how we roll. Will, are you okay?
Yeah.
All right, good. Were you choking on your crappy son?
I don't know what I was
Joking on won't spit. Secant line intersects in more than 1 point. It could be 2, could be 3, could be a gabillion. Yeah. All right, so we're gonna look at this guy. This will be fun. This is going to explain everything. All right, so I start with the point P. See it over there on the left-hand side?
Yes, sir.
Good, don't call me sir. P is located at the x-coordinate of x. It's located at the y-coordinate, because this is calculus, of f of x. Nothing fancy-schmancy there. Oh, we are starting with this curve, which is the blue thing. Probably a cubic, I don't remember to be honest. And then from P, I'm going to move over some horizontal distance. How far am I moving over? I'm moving over delta x distance to get Q. See Q up there in the upper right? So therefore, the x-coordinate of Q is x plus delta x. And it doesn't matter where these are located. I happen to put x on the left-hand side of the y-axis. I could have put it on the right, it could be very close, it could be very far, it doesn't matter. Q is going to be located as x comma delta x. Therefore, the y coordinate of Q is up here on top. F of x plus delta x. That looks familiar, doesn't it? Doesn't it?
Yes. Yeah.
Good. What's the slope of that green line? This is an Algebra 1 question, by the way.
Changing y over changing x.
Delta y over delta x. Perfect. Now be more specific.
F of x plus delta x minus f of x.
Whoops, x plus delta x minus.
F of x over x plus delta x minus x.
Which would be equal to whoosh, whoosh.
Delta x.
Yeah. Does that look familiar?
Yeah.
Oh yeah, you've done that before. Okay. Here we go. Now we're gonna get all fancies in our pansies. What happens if Q starts moving along the blue function towards P? What's gonna change? I'm sorry? Yeah, what's gonna happen to delta x? It gets smaller. It continues to get smaller until eventually it reaches what number? 0. What do you call that when a number gets really small and approaches some other number? A limit. Wait. Yeah. Oh, it's going to be great. Watch this. Watch this. It's going to be cool. Okay, so hopefully you realized that the green line is a secant line, yes?
Yeah.
It intersects the function in 3 spots. The red line is a tangent line. Intersects in only 1 spot. If we do a little bit of magic here, oh, Q's moving. It's moving a little slower than I planned, but it's moving. It's getting closer. Delta x is getting tinier. Smaller and smaller. Probably should have moved Q closer before I started this. But it's getting closer. It's getting really small. Look how small delta x is getting. What's going to happen? Yeah, watch that green line. Delta x gets tiny, 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 and bingo! It's 0. We get a tangent line. So we can turn the secant line into a tangent line if we make delta x go to 0, which we know as a limit. Hot diggity. Let's look at the math then. Shut up. Not you, the computer. Okay, so we did this already. There's a slope. We did this. Oh, x minus x is 0. That goes away, and we end up with that. Okay, so that's the slope of the secant line. But we want to turn the secant line, the green one, into the red one. So I move Q closer by making delta x go to 0, which is the same thing as a limit. And when we're done, we'll end up with the slope of the red line, because we want the red line slope, not the green line slope. No, we don't need to go back there. Talked about this already. Oh, there it is. It's in a blue rectangle. It must be important. Probably want to write that down. The slope of the tangent line, which is the red line, is found by taking the limit then as delta x approaches 0 of that difference quotient. So that's the concept. The math, I think, is a little bit more interesting and I think easier. You might not agree. We can fight about it later. We signed up for a free cruise. Okay, we good? How do we apply this? Have you done derivatives in maybe physics? A little bit? So you've dabbled? Yeah. This is what's called the formal definition of derivatives, also known as the limit process. You will have to do this for a little while. Then we're going to start learning all these other tricks to make your life a lot easier. Okay, but we need to respect this first and do it for a problem like this. So we got a parabola. Katie, what can you tell me about that parabola? Anything?
It's gonna open up.
Beautiful. It opens up why?
The lead coefficient tells us.
Excellent. Do you know anything else about it?
No.
Okay, that's fine. That's an acceptable answer. What do you want? You want to fight? Yeah. Let's go. Now? Okay. What's your question? It does pass through the origin. Because 0, 0 satisfies the condition. There are any... Yes, sir. Go ahead. It could be good. Could be
I
silly.
was gonna say what the y and x intercepts were. But then like,
What are they?
We don't get
Okay.
0.
There are an infinite number of points on that parabola. What we want to know is what is the slope of the tangent line at a particular point, 4, 40. How do I know far? Just developed another accent there. How do we know that far? Party is on the graph. If you plug in far, you're going to get hard.
Michael McGovern.
So, it only happens to work at that particular point. This is what bothers people, is you'll see as we do the math, your answer for the slope is not a number. It's an equation. What? Yes, it's an equation. I'll explain why in a second, so let's do the math. We're going to need some working space here. Whoa, it's already done. Let's get rid of that. That would be cheating. Okay, here we go. F of x is 3x. Was it minus 2x or plus 2x? Minus 2x. I don't really know, but let's pretend my parabola looks something like this. Okay? Depending on the point that I choose, will give me a different slope of the tangent line. So for instance, if I pick something around the origin, I will get a tangent line that is fairly horizontal. In fact, it might be exactly horizontal. If I move to the right, my tangent line would be something like this, some positive slope. If I move to the left, I get some negative slope. So you can see that depending on where you are on the parabola will give you a different answer to the problem. How are we liking the black background, by the way? I'm branching out a little bit. I'm feeling...
Thanks to Emily.
Yeah, you do all your notes for the black background, right? You're my hero. No?
They're a little bit too thick.
All right, so here we go. The slope. Whoops. For this particular problem, what is f of x plus delta x?
So 0.
Nope. Jacob.
3 times x plus delta x squared minus 2 times x plus delta x.
3 times x plus delta x quantity squared minus 2 times quantity x plus delta x hot diggity. Go to the function wherever you see an x, put in an x plus delta x. Minus. Now I don't remember if I had this in the blue rectangle, but get in the habit of adding parentheses after that minus sign. Very important. F of x, 3x squared minus 2x. All over delta x. We're taking a limit. What's the first thing you do? Plug and chug. I'll save you the hassle. It doesn't work. 0 over 0. What do we do next?
Change it.
What is... Okay. Change it. Good. Ah, 3x squared plus 6x delta x plus 3x or delta x squared minus 2x minus 2 delta x minus 3x squared plus 2x all over delta x. Oh yeah, that just happened. Not yet. It's coming though. In fact, I'm gonna change colors for it. I don't know, what's a good whoosh color?
Like a light purple.
It's gonna be like brown.
The magenta? Pink? This one. Alright, I'm going with that. For those of you that I lost, squaring x plus delta x, square the first term, multiply 2 together, double it, square the last term. X squared plus 2x delta x plus delta x squared. Then the rest is all distribution. Now we cancel. Negative 3x whoosh, with 3x squared. Whoosh, 2x, negative 2x. Whoosh, whoosh. Ooh, I'm happy. I'm happy because everything I have left up there has a delta x in it. Oh, yeah, you bet you can. Hold on a second, because I'm going to show you what not to do. A common mistake that people make is they take out their whoosh pen and they go, oh, wait a second, I've got a delta x on the bottom, and conveniently enough, I've got a delta x with, oh, I don't know, the 6x delta x. So I'm going to do this. Whoosh, whoosh. No, bad math.
Factor it out.
Correct. Factor it out. Switch back to white first, then factor it out. The limit as delta x approaches 0. Ooh, helpful hint for the test on Thursday. Notice I'm writing the limit every time. What was that? Well, then don't. Fine. Shut up. Whoosh, whoosh. Almost there. What's the limit as delta x approaches 0 of 6x plus 3 delta x minus 2? 6x minus 2. Whoa, what? Hold on. We just took a limit, and instead of getting a number, I got an equation? For a line? Shut the front door. How is that possible? Liquors is a good one. I'm totally stealing that. I haven't heard that in years. Carnation. Well, what does that mean? Well, let's suppose, I don't know, we put in a point then, because as I showed you in the picture, the slope of the tangent line will change depending on where you are on the function. I don't know, what point can we put in there? Well, the problem asks you for 440, so let's do that. The slope is 6x minus 2, and we want to do it at the point 440. Therefore, the slope would be equal to 22. See? See. That's a big slope, but that's okay. Well, part B of that problem said, wait a second, I don't just want the slope. I want the equation of that red tangent line. What are the two things you need for an equation of a line? Point and a slope. Do I have a point?
Yes.
440. Do I have a slope?
Yes.
I'm assuming you can all put it together in the equation of a line.
Yes.
Y minus 40 is equal to 22 times the quantity x minus 4. Woohoo!
That's not a really good part of it.
What?
It's like baby part three.
How do you know what baby part is?
I haven't done it.
It's a hobby of mine.
See all these equations that they
Oh, that's better. Ooh. Yeah, the yellow's kicking.
It's like a gold star, you know what I mean?
Did I lose anybody in that process? Oh, I just realized one bad thing is I've got Green Bay Packer colors up there. Are we good? Are we good? Are we good?
Yeah.
Let's see what we can do with that now. None of that process that we just did requires any calculus. And in fact, I could have taught that to my freshmen in geometry. So now we want to incorporate some calculus into this and start explaining how this applies to what we're going to be doing. Oh yeah, here's the solution. Scott did that. Yeah, see, oh yeah, mine was better. Didn't have the whoosh noise. You know what I'm saying?
Yeah.
You can add it.
Oh, okay, hold on. Whoosh. Whoosh. Same answer?
Yeah.
Same? Okay, good. Ooh, that looks like some calculus. Nah, not really.
You wrote that down.
Notice that's in a different form, by the way. Change the x's to c's. It's the same thing. You'll see a couple different forms. Let's get some where's calculus here? Oh, hold on. Vertical tangent line. Give me an example of a function that would have a vertical tangent line someplace on it. Jacob.
Transfers infinity, using that equation we just did.
That's an answer to a question I didn't ask, but a good answer.
Okay.
What would a function look like that would do that?
You know what it is, the semicircle.
Semicircle. Semicircle would work. Gotcha. All right, so if we have a semicircle, let's say with a radius of 4, and up here at 4, what's the slope of the tangent line at x equals 0? At x equals 0, what's the slope of the tangent line?
0 on 5? No, it would be y equals. Y equals 4. Be horizontal.
Hold on. Answer the question I'm asking, not what you think I'm asking. What's the slope of the tangent line at x equals 0?
It's 0,
Why, Kimmy?
because it's just a straight line.
Well, all lines are straight, but
I meant not straight, but it's the point at 0, 4, so it's horizontal.
there you go. That's the word we're looking for. Horizontal tangent line. Whoop. Have a slope of 0. As I start moving to the right, what's going to happen to the slope of that tangent line? Let's say I go over here to do.
It's going to be negative slope.
Good. Looks something like this. And then what happens if I go to tree?
Just keeps getting more negative.
More negative. And then I go to 3.5.
Even more negative.
More negative. 3.75.
Even more negative.
3.8.
More negative.
Till eventually I get really, really close to 4. What's the tangent line going to look like?
Undefined.
Right, because it becomes vertical. Very good. Got one here. So we go from 0, negative, big honking negative number, very big, the biggest negative number, which would be negative infinity. All right, go to the left. What's the slope of the tangent line at negative 2? Some positive value as I move further to the left.
Positive infinity.
Bigger, positive infinity. Correct. Good. Any other functions that have a vertical tangent line?
Parabola.
What kind of parabola?
Negative.
Upside down? Like that?
Couldn't it be both? Couldn't it be both?
Where's the vertical tangent line here?
Like almost like, like the tip.
Here?
Yeah.
But that goes on forever.
I don't know, you just gotta find it.
You just keep going?
You're gonna find it.
Yeah, I gotta find it, even though it goes on forever. That'll take me a while. Okay, that won't work, by the way. However, you will see some functions like this. Wait a second. Like that, that'll generate a vertical tangent in the middle of just a plain old regular function. Start moving along here. 0 starts getting bigger and bigger and bigger until it gets the biggest it could possibly be, and then starts curving back to 0. Okay. How do you know when you have a vertical tangent? It's when one of those two things pop up. When you plug that stuff into the equation, that difference quotient with the limit, and you get infinity or negative infinity, you'll have a vertical tangent. The end of semicircles, the end of a square root function. Now it's got that top half of the sideways parabola. Back at 0 there, it would also have a vertical tangent line. Okay, well that's not real exciting. I mean, it does pop up every once in a while, but it's not crucial. What is crucial, though, is some calculus here. So now we give it a fancy name. We don't just want the slope of the tangent line, because that's Algebra 1 stuff. We want to make it our own. This is calculus now. We're running with the big dogs. We've come off the porch. So we start calling it a derivative. Eventually, we'll have 3 properties of that derivative. Here's the first one today. It's the slope of the tangent line. And you got some notation there. If you can't see, well, you should be able to see it. There's a TV right in front of you. There's an apostrophe in there. That's read as f prime of x. So f prime of x is the slope of the tangent line at x, also known as a derivative. Derivative is a noun. Differentiation is a verb. Is it an adjective? That's a verb. It's an action verb.
Adverb.
Adverb.
Or a pronoun.
Or a modifier.
Or a
Onomatopoeia.
We don't write pronouns. Constant.
I don't even know what I'm talking about. That's why I went into math. I could barely read. It's a hyperbole. Simile. Or a metaphor. It's a metaphor for life. Whole bunch of different notations, and I'll explain why we have different notations in a minute. The most common that we're going to use are the first 2 on the left. F prime of x means the derivative of f with respect to x. The second one, dy over dx, means the derivative of y with respect to x. Fortunately for you, we're doing single variable calculus, which means that any time you're working with a function, you'll only have one variable. Even if there's multiple letters in it, you'll have x's and y's and z's and all that other fun stuff. Only one of them will be considered a variable. There is a whole other branch of calculus called multivariable calculus, where you're solving problems where 2 of the letters are variables. Avoid that as much as possible. It's icky. Anybody going into engineering? Yeah, I don't think you'll be able to avoid multivariable calculus. What kind of engineering? Yep, you're done. What kind of engineering? Maybe. Who else raised your hand?
Aerospace.
No, you're done. Multivariable coming your way, like probably freshman year. Okay, so Isaac Newton. Quick history lesson here. What's Isaac Newton famous for? The apple. What does that mean? He invented the iPod?
No, like the apple, like he shot on a tree and apple like hit him in the head.
Yeah. Concussed, probably. And he's just famous for getting hit in the head with an apple.
And then try to figure out like why.
Why he got hit in the head with an apple? Well, he's sitting under an apple tree.
No, but like yeah, he was wondering like why he felt that way.
No, that's it. Right. Nice. 3 laws of motion. Right? You've all had physics, right?
Yeah.
Object in motion remains in motion unless acted upon by an outside force. The F equals ma, and
Left hand limit equals right hand.
no, that's not. What is the 3rd law of motion?
It's
Oh yeah, for every action there is an equal opposite reaction. Okay. Isaac Newton was a jerk.
He stole from me.
Yeah. Oh wait, I got some hair. Hold on to your seat. Wait till you see this next guy. So Newton at the time was a celebrity. Back then, mathematicians like Newton were like rock stars. He's like the Justin Bieber of his time.
Oh, God.
People would stop him on the street, ask for autographs, the whole business. He was in charge of an international mathematics society. They would get together, do math problems. You know, that's how they rolled. Have Tree Tuesdays, yes. And he created calculus. The reason there's multiple notation there is because Newton used the f prime of x notation and creates calculus. At the same time, this guy, are you ready for this?
Yeah.
Wait till you see this here. This guy, that's pronounced Gottfried, not Gottfried.
Got fried.
Like, go do some calculus, man, it's awesome. Gottfried Leibniz creates calculus on his own. Different parts of Europe, they don't know each other. Leibniz doesn't get invited to all the cool math meetings like Newton does, but he comes up with similar ideas, in fact, almost identical ideas. His notation, however, is the dy dx notation. Same ideas, different notation. Newton hears about it, and he's pissed. This guy's taking his thunder. I can't have that. So he spent the rest of his life, aside from being a celebrity, ruining this guy's life. It's horrible. I mean, the guy died broke. He didn't even have money for hair care products. Can you imagine what that hair would look like without hair care products?
On like a humid day.
Not a humid day with no hair care products? That would be embarrassing. Could go out in public. Right. So, that's why we have multiple types. Oh, I forgot this too.
Ladies and gentlemen, let's get ready for
Newton gets.
Probably wearing a wig.
His thing. It's not his real hair. No way.
How do you know this?
If he dies broke, he's just going to have some short hair on. He's not going to have that wig.
What makes you think it's a wig? I mean, somebody could grow hair like that.
People wore that more often back in that time.
Maybe he wore it up in a man bun.
He's like, I'm stumped.
Can you imagine the size of a man bun? Okay, so that's why we have multiple notations there. F prime of x, dy dx, and then all those other weird ones that pop up are just other people saying, oh, let's do this instead. You will realize quickly, and there's a reason why I chose this problem, that this limit process can get really nasty. The first one that we did was a quadratic. It wasn't horrible, it was doable, but it wasn't fun. This one would be a lot more funner. Because now all of a sudden I've got a function that's cubed. And I have to take x plus delta x and cube it. Is that going to be fun?
Yeah.
Yes, it will. Correct. However, there is someone that can help you with that. What's his name?
Godfrey?
Factory.
What's his name?
Frank the Factory.
No, not Frank the Factor. No, he's on vacation. Famous mathematician, made a triangle.
Pythagoras.
No, not Pythagoras.
Had five goals.
No,
Aaron's
no,
formula.
not Archimedes.
Aaron's formula.
Archimedes is famous for what? Running through the streets naked, yelling Eureka, Eureka. Eureka, Eureka. Eureka means I found it. You ever heard that story about Archimedes? Not urethra. No. Okay, so Archimedes, hired by the king, somebody gives the king a present and says, hey, this present, I think it was a crown, is made of gold. And the king doesn't trust the guy. So before he kills the guy, he says to Archimedes, hey, can you figure out if this is made of gold without ruining the crown? So Archimedes is thinking, how am I going to do this? How am I going to, I don't know. And he's in the tub. And when he sits down in the tub, the water overflows the tub. So he discovers Archimedes' principle. Well, he gets so excited he leaps out of the tub and starts running through the town naked, yelling Eureka, Eureka, which means I found it, I found it.
Yeah.
Which probably disturbed a lot of people. But This is, what I was talking about is Pascal's triangle.
Oh.
Remember that?
Yeah.
1, 3, 3, 1?
Yeah, one.
So if I'm doing x plus delta x quantity cubed, using Pascal's triangle, I would have x cubed plus 3x delta x squared plus 3x squared delta x plus delta x cubed. If you didn't remember Pascal's triangle, then you just have to multiply that bad boy out, which is a little nasty. So you'll see, we go from a quadratic to a cubic. It gets much, much nastier. That stuff I have on the board is just x plus delta x quantity cubed. I got to tack onto that another 2 times the quantity x plus delta x. Then I got to stick on another x cubed plus 2x behind that in parentheses. Then I got to put it all over delta x and take a, and you can see how bad it's going to be. How could I make it worse?
Putting it to the 4th power.
4th power, yeah, it's increasing the
Powers.
What do you mean, like?
having a brain fart.
Coefficient power?
The degree,
The degree.
yeah. How else?
Putting on a coefficient in front?
Ooh, how about a fractional coefficient? Oh, wait, how about a rational function? Oh, wait, how about a trigonometric rational function? So, my point being, it could get really ugly. So what we're going to do is get through this limit process thing as quickly as possible and start learning shortcuts. So for instance, one of the shortcuts you'll learn is that I can do the derivative like this in a heartbeat. The derivative of that is 3x squared plus 2. You'll learn the same tricks. But until we get done with this limit process, well, how do I know when I can use the tricks versus doing that big scary limit as delta x approaches 0 of f of x plus delta, or f of x plus delta x minus f of x all over delta x. If it says using the formal definition of derivatives or the limit process, you got to do that other bad boy. Right? We're having fun, right? Sarcasm. Let's stop here. Because that's going to take a little bit of discussion and we don't have enough time to get that covered, but we will have covered enough stuff to allow you to get a majority of the homework done, if not all of the homework for the first semester. Okay. Problems, questions, concerns? How are we doing on the donuts? All gone?
No,
You guys just killed the rest of that dozen?
no.
I mean, no judgment, you could have.
The one that you said looks so gross, it smells so bad. Like,
Is
I
it,
can't
well,
sit
smell it, is it maple?
It's maple.
Maple donuts, did you ever have maple bacon donuts?
I had
Oh, I loved it. I loved that.
We have already
I've had chocolate covered bacon also. Some good stuff.